Hello and welcome to the last talk for today. My name is Marius and I will talk about Qt and OpenAPI and Swagger. This talk is a follow-up talk from the Qt Dev Days 2019. A colleague of mine talked about Qt and the web, and he talked about how the web influenced the software engineering field in the last 20 years and how Qt does fits in there. Um, he mentioned Swagger a bit, but there was no time to go into detail, and that's what we're going to do today. But first, a few words about Basiscom and about me. Basiscom is located in Darmstadt and Nuremberg. It is specialized in Qt and industrial applications of Qt. Most of the products are measurement applications, manufacturing and industrial automation, and most of the customers are machine builders from the DACH region. And about me, my name is Marius Dege. I work for Basiscom since 2020, and I'm a master student at the University of Applied Science in Darmstadt. And I worked with Qt in my bachelor thesis, and I'm also an active contributor at the OpenAPI Generator project. And we are at Basiscom are often in situations where a Qt application has to talk with a web API, and more specific within Swagger API, and that's why I want to talk about this topic today. But before we start, a small overview about the outline for today. First, we want to see what is OpenAPI and what is Swagger. Then we want to take a look at different OpenAPI implementations. These are projects that are implementing OpenAPI, the OpenAPI tooling, which you can use in your project. Then we want to take a look at the tools and the workflows that those implementations provide before we see how Qt fits in the OpenAPI world. Next on is a hands-on session. So I'm going to show you how to use the OpenAPI generator in a Qt project, how to generate code and how to integrate the generated code. Then we will take a look at our contributions because we as Basiscom always try to contribute back to the projects we are using. And I will give a small overview about what we did so far and what we want to do in the future. Then in the end, I will wrap it all up with a quick summary. So, what is OpenAPI? What is Swagger? Most of you probably heard about the terms already, but I will make sure that everybody knows what we're talking about. So, a quick definition. OpenAPI is a specification of an API description format for REST APIs, and it was created to have a standard on how REST APIs are described. It was born out of the Swagger project, and it formalized what was already there. Swagger then became a tool set to design, test, and maintain REST APIs. One of the biggest selling points is that you can generate client and server code for over 40 languages and frameworks. And here's an example of an OpenAPI document. It's a Swagger document because it's a bit older. It uses the version 2.0, and you can see there's a description and a bunch of things here, but we won't go into detail here because we will have a closer look on this document later on in the talk, just to give you an idea on how an OpenAPI document looks like. So the terms Swagger and OpenAPI often mix up quite a bit. As you saw in the document, there was Swagger at the top, but you could also write OpenAPI. So I will give you some historical context so you know why those terms are mixed up sometimes. In 2011, the original Swagger API project was created by Tony Tam, and SmartBeer Software then created the OpenAPI initiative, and It is supported by the Linux Foundation. A year later, the Swagger specification was renamed to OpenAPI specification. That's why you saw in the document the Swagger at the top. Now there would be OpenAPI at the top. So in general, when we talk about OpenAPI or OpenAPI specification, we talk about the industry standard for REST API design. And when we talk about Swagger, we are talking about open source tools that are working with OpenAPI documents. So Swagger was the original um, implementation of such a tool set to work with such documents, but nowadays there are some more implementations. Um, but before we go there, we want to take a look at the Swagger code generator. There are two branches for each version of the OpenAPI specification. So there is a Swagger code generation for OpenAPI 2.0 and 3.0. And there was a problem. So many members of the original project were concerned that the branches were divergent too much from each other, and that there would be too much maintenance overhead for two separate branches. So they the main concern here was that this would lead to results similar to those felt in the Python community with these two branches, version 2.0, 3.0. And so there was a fork created called OpenAPI Generator. And the reason I bring this up here is because the forked generator provides more support for Qt and does some things differently, but we will talk about this later on. So now to the different OpenAPI implementations. As I said, there are more around. Um, First of all, the Swagger project. This is the original project, and this is a set of open source tools that are built around OpenAPI specification, and that can help you design, document, and consume REST APIs. I put on their website here, swagger.io. You can check it out if you want. And next up, there's the fork, so the OpenAPI generator. As I said, it is forked from the original project, but it only forked the generator itself. So there are some more tools provided by Swagger that you can still use when you want to use the OpenAPI generator. So you kind of use a mix of Swagger tools and OpenAPI generator. Um, yeah, so there's also Azure Autorest. It is also a code generator, but it does not support Qt, so I won't go into detail here. Um, yeah, so next up, we want to talk about the tools and the workflows that are provided by those implementations. And since the Azure Autorest does not support Qt, we will just have a look at Swagger and OpenAPI Generator. So there are a bunch here. There are some more, but I only want to talk about the most important ones or the most useful ones here. Um, and first of all, we have the Swagger editor. So this is a powerful tool that allows you to test, modify your API endpoints in the browser itself. So you have a view where you got your document, your OpenAPI document on the left-hand side, and on the right-hand side, you see the endpoints that are described by this document. You can play around, you can test them out. We will have a look there later on. We will open the Swagger editor in the hands-on session, and I will show it to you. So next up there is the Swagger UI. You could say the Swagger UI is a subset of the editor because it will give you the same interactive UI that you got on the right-hand side in the editor, but the editor itself is missing on the left-hand side. So it's just for have a look at the endpoints and what the API provides. But you cannot change the API on the fly there. So, and the Swagger CodeGen is the third tool. in the Swagger project, and this is to generate code, server and client code from an API, OpenAPI specification. And last but not least, the OpenAPI generator. And as I said, it's the fork from the Swagger code gen, and it does the same, but it does some things different. And especially if you look in at Qt, and I will come back to this later on. What's the difference and why I will bring this up here. So, but here's a picture, a screenshot from the Swagger editor. So this is a browser, and you can see on the left there is the input file, so the an OpenAPI specification, and it is the pet store, the Swagger pet store, and this is the go-to example project from Swagger. Um, you can see on the right side there are a bunch of post, put, and get. So you see some HTTP verbs here. For those of you who are not familiar with REST, REST is using the HTTP verbs, so that's why they will come up here. And you can also try them out in the browser directly, um, and you will see that later on in the hands-on session. And now the UI looks pretty similar. Only thing missing is the editor page on the left side. But as well, you can try out the endpoints, the API. You can make requests in the browser directly to the server, and that can be pretty handy. So now we talked about OpenAPI, we talked about Swagger. Now everybody should know what it is about, what you can do with it, and why it is, yeah, nice to have. And now we want to take a look um, in to Qt. So how does Qt fit in the OpenAPI world? Um, and I want to start off with a first overview of the state of Qt support in Swagger. Um, and more precisely, we take a look at the code generator. And first up, there is no code generator for the server side. Um, so Qt does not provide an official API for implementing HTTP servers, but there are other generators for C++ HTTP servers, and they might work for your project. So this is not a big deal. But for the client code gen that is supported, and it works quite well, the Q network access manager is being used behind the scene there, but there are some downsides. The code gen does not support OpenAPI 3.0 documents. This is due to the fact that they have two branches, as I mentioned earlier, for each version, 2.0 and 3.0. And the code gen for from Swagger 3.0 has no Qt code generator. And so we found the quality was a bit lacking on Swagger. We also encountered some bugs that blocked our use cases. That's why we decided to use the OpenAPI generator, so the fork of the generator, of the Swagger generator, for create our Qt clients. And as I said in the beginning, we also contributed to this project, but more on this later in the talk. But in general, if you want to use Qt with OpenAPI, we recommend you to use the OpenAPI generator. Yeah, because the community is more active, way more active, and you have better Qt support in general, and you can also use OpenAPI 3.0 documents to generate your code. So next up, we got a hands-on session here. So you guys know what we're doing here, and we have a small example program, machine terminal, and I want to show you how to use the OpenAPI generator, how to integrate the generated code into an existing project, and we want to build a hypothetical woodworking machine that is processing orders from an ERP system which is offering an API, and REST API based on OpenAPI and Swagger. Um, I will show how to interface this API in this hands-on session, and our goal here is to build a Qt Quick HMI that uses the provided API, but we don't want to write all that boilerplate code that is needed to interact with an API. So we don't want to get our hands on the Q Network Access Manager, and we don't want to think about communication details like serialization or all the transportation and networking stuff. So we don't want to get our hands on there. We just want to generate the code and just use it. So we jump straight into the browser. And as you can see, on the left there is also we are at the Swagger editor, like you saw on the slides, and on the left there is the API we're going to use, so the OpenAPI specification. It's a sample ERP server for distribution of jobs, and you can see there are some many things here. We won't look at everything here, but on the right you can see there are the three main things we looking for. So there are our endpoints. Um, we can list our orders because it's all about orders here. We can find an order by ID, and we can update an order status with a partial order object. You can see there's also a model tab here. This will show how an order is looking like. So there are some variables here, like what kind of wood, an ID, what quantity, the dimensions here with the height, length, and width, and stuff like this. Um, and you can see here are the list orders. You can just try it out in your browser. Let's say we want to get all pending orders. We execute it, and then we get a response here. This time we get network error. Um, this is due to the fact that the server is not running yet. I will just go ahead and do that really quick. So server is up and running, and if we execute it, you will see we get a bunch of JSON data here, and these are all the pending orders. The server itself, we don't care about the server right now. We just want to use the API. So we don't want to get our hands on the stuff behind the scenes. And you can see on the left, real quick, there are some paths here, like the order path and the get, and you can see there are parameters like the name status, and we have to set it, and there are some items in an enum, so we can search for there. We can list all pending, processing, processed orders, stuff like that. The other path here is also a get, where we can get an order by ID, but we can also patch an order. So update an order, like you see here, update an order status. So this is the API we're going to use. I will now jump in straight to the Qt creator, and we have our machine terminal example program here. It consists of one class, ERP service, and three QML pages here. I will start off with a header. You can see there's a bunch of stuff already because we don't have too much time here. So I already provided a header file here. You can see there are three functions, and those are the main functions we're going to use. And they look quite familiar. So we have get order by ID, list orders, and update an order. And this is the same we got here. So now we can take a look at the function bodies. They are all empty right now because we're going to fill them up in a minute. I will just show you the project here, the structure. In the main, nothing much going on here. We just set the ERP service in the root context of the engine, so we can use it later on. Load up the QML, and executed. So the QML is pretty simple, nothing too special here. There's only a small menu at the top corner, and all the pending orders later on will be displayed here. So the pending orders page, nothing too special as well. The orders will be listed in an item delegate with an ID and the type of wood and the dimensions. There's also a timer that will trigger an event, and it will list all orders from our ERP service, so from our own class here. And there's also a connection with a signal here. When we get the order, so when the list orders is finished, we will sort the orders and display them correctly. I won't go into too much detail here because we don't have too much time and it's not the main thing I want to show you. The order details are worth to mention, I guess, because this is the picture you saw on the slide. So we have a generic picture in the top, and then we have our wood and our dimensions here and some buttons. So if we take a look at the buttons here, down there they are. Their onClick function calls an update order status function with different status, and this function will eventually call update order with from our EP service. So we got our function here, and that will be called here. And at the same time, it will be connected with the update order finished signal, which is also from our class. And this is here. And the reason for all the signal and slots here, you can see there are a bunch, 2 for every function. So get order by ID has their own signal and their own slot. And the reason we are using this is because the generated code relies on signal and slot connections, and we will now generate the code and include it in this project here. So right now the project does not very much. As you can saw, the function bodies are all empty. Only thing that really is there is a bit of QML, but that's not the point here. We now go ahead and visit the website from OpenAPI Generator. Since you now have an idea of what we are talking about in the example project and what it is about, and now we want to generate code from our API. So we go ahead to install. There are a bunch of install options. You can use npm, homebrew, maybe, or Docker, but we just want to use the jar file. So you can just use wget and download the jar file. I already did that. So here it is. And here's our OpenAPI specification, so our file. This is, by the way, the same file we saw here. That's why we got the same functions here. Now to generate the code, we need to open a terminal. We can type java-jar and use our jar file. And then we say we want to generate. Then we want to input -i our Swagger file or OpenAPI file. It doesn't matter what you're using here. And then we want to use the generator called cpp-qt5-client because we want to use client code for Qt. Then we have to say where we should output the generated code, and we just put it in our machine terminal folder. So if you're going to take a look here, this is our project folder. There's our class, our QML, and once we hit enter, a bunch of files are created. And if we take a look here, the client folder popped up. So if you go there, we can see there are a bunch of files. Um, I won't go into too much detail here because most of the files are just helper functions. They do the HTTP work, so the all the transportation, serialization, there are helper functions, and we don't care about them. So we just want to use them. We don't want to see the network access manager that is somewhere in there. Only thing we need to care about is our order and our order API, and as well as the client.pri, because we want to integrate it into our existing project, and the code generator also generates our client.pri, so we can just include it. There's also CMake support, which can be pretty handy as well. So we just jump back to the Qt creator. So now our code is created for the API, and now we want to integrate it. So we jump ahead in our machine terminal, and we can just type include the client folder and include the client.pri. So pretty straightforward. We hit save, and yeah, there it is. There's our client folder, and you can see all the classes that you just um, saw here. So as I said, we won't go into much detail here because it's mostly helper functions to string value from JSON value, stuff like that. We don't care about that. We just want to use it. And we will take a look at our order object here, or our order class. You can see it got its own namespace and a prefix here. Every class got a prefix here. You can set the prefix and the namespace in the OpenAPI specification. So if you have a document there, you can just set your own namespace or prefix if you want to. We just stick to the default ones here. So next up, we want to take a look at the order API, and there's a bunch of helper functions as well. We don't care. The only thing we care about are these three functions. So if you remember correctly, there's get order by ID, list orders, and update order with. Again, those are the same ones we saw in the browser. And those are the ones we're going to use to receive data from our server. Um, so one more thing here, because I talked about some connections, some signals and slots in QML and in our header as well. The reason behind it is that when we take a look at the function from our API, we can see it does a bunch of things, something with HTTP, but we don't want to look at that. The thing we're looking for is the callback, because every function has a callback that is connected with the on execution finished signal. So basically what happens, we call the function, or from our API object, we call the function. This function will speak to the server, receives the data, calls the callback function with the signal and slots here, and in the callback, the data is parsed and then emitted with a signal. And you can see there are a bunch of signals here, 4 signals to be precise, and there will be a check for error type. If there is no error, the normal signal will be emitted. There's also the signal full that will be emitted. It's the same, but it will provide the network request worker as well. But we don't need that. We just want the data. So we just want the output, the data from our API. But if there is an error, so let's say network is not reachable, the get order by ID signal with an E suffix will be emitted. So these two signals are the ones we care about. And so again, to make it clear, because it can be a bit confusing, we have our OpenAPI order API. So we have our object, we call the function. This function will do all the communication with the server, and eventually at one point it will emit a signal with our data that we want. So what we have to do in our own class is we have to connect with our signals, with this signal, with our slot here. So we got a slot um, for every function, and we will connect on the uh, signal from our API with our class, so we can receive the data. And then once our slot function receives the data, it will emit our own signal, and this signal is connected with QML. So that way we can get the data in QML in the end where we want to display it. So all the connections here are a bit confusing, but I guess you will see what I mean in a minute. So we just go ahead and start to include the files that we're gonna need. So we include from our client our OpenAPI order, because we need the order, obviously, and we also include our order API. So that is all we need to include here. We don't care about the rest and we don't need it, but we need an order API object. So we go to the OpenAPI namespace and make an order API object. Um, we want to make it a pointer and we call it order API. So this is everything we needed to do in the header. Um, I went ahead and already put the correct data type here in the slot functions. So because we're receiving orders, everything is about orders. So we receive our order here. So now we're going to our source file, and we need to initialize our order API object, obviously, and we want to make it a new order order API. Call it with no arguments, and it should be good. So now in the constructor we need to do all the connections I just talked about. So we just type connect, and we want to connect. So our sender is our order API object, and we want to connect with the Open API order API, and there are our signals. So you can see this is our signals for every function. There are 4 signals. We just need 2 of them. So we take the get order by ID signal, and we want to receive it here, and we have to because we want to receive a summary and an order here, we have to do this here really quick. So we want to receive an order object called summary, because it's called summary down here as well. And we want to connect it with our on get order by ID returned slot. So this is our slot. We want to connect the signal from the API with our slot in our own class. So we pass in the summary here and finish it up. So we got our first connection. Now we're going to do the same thing with the error signal. As you remember, we can also run into an error, and we want to be prepared. So we need to put an E here, because now we're talking about other signal, and we can just remove the summary, the order here, because we won't receive any data when we run into an error. So we can get rid of that and just put it like this. So obviously we need to go with our ERP service namespace, and then we're good to go. So this is for our first function, so for our get order by ID, but we want to do it for list orders and update orders as well. So we can just go ahead and copy that, make some space here. And now the only thing we need to change is the signals in the slots, obviously. So we got our order by ID, and now we want to list orders. So there it is, list orders signal. Same goes here, list orders. We just finish this one first, and we want to on list orders returned with the summary. There's one thing here, because the slot here is expecting a queue list, so we obviously need to provide a queue list. So this has to be done. So now that's fine. We got our list order signal. It's now we need to have our list order signals with the error. And again, we don't need to have our queue list here, our orders, because in an error case there is no data. And now to the last one, and it is the update order. So we have our update order signal. We can just leave the order like it is because we just update one order, so there's just one order and not a list of orders. Now change up the. Oh wait, we forgot something. We need to. Obviously, we don't want to connect it with our on get order by ID lists. We want to order by ID returned. We want to connect it with on list order returned. So, and same as here, we want to have our on update order with returned, and same here on update, and the right signal here, the error signal with the update order. So this is all the connections here. Maybe a bit confusing, but it's two connections for each function. And again, as I said, it's because we have to rely on all the connections between QML, our API, and our own class. But now we can just go ahead and delete our order object later. And then we can just use this order API and just call get order by ID. And this is pretty simple now. We can just go ahead, just create like this. Now there's one thing on the update order with, because we have a variant map here, but when we take a look at the function, it wants to have a partial order. So our order ID is fine. Now it wants to have a partial order object. This is as well a generated class, but it's only for status. So yeah, but we just accept that. Just create our partial order object, call it partial, and we can say from JSON object, and then we can put our update. Now we need to generate a JSON object, and then we can say from variant map, put our update here. So updates contains the new status that we want to set, and now we can set the partial there. Now for the slots, the slot functions, we want to emit the signals that are being connected with QML. So we could just go emit and then get order by ID finished. But since there could be an error, we will check for error type. If there's an error type, we will still emit the get order by ID finished, but we will call it with an empty variant map because we have no data. We put our error type and our error string. So now in our else, if there's no error, we can just use the normal signal here, emit, and we can just pass our summary, but as a JSON object and to a variant map because we want to pass a variant map to the signal. Later on here we can just go ahead and copy that because we don't have too much time here, and it's actually not big of a difference here. Only thing again, we have our queue list here, so we have to make a queue variant list and have our list orders returned finished. And now we have to create a queue variant list here, call it order list, to you have all the to get the summary in an order list and then pass it onto the signal. So what we're going to do is we just going to use a for each loop, get every order in our summary, and then just put it in our order list. So like this, but we can't just put it in there because we need to cast it, use it as a JSON object. And again, this is a helper function from our classes here, so we don't need to implement that. Now we can just put our order list in here. So last but not least, the update on order returned. The wrong signal here. This order is finished. And now we change this here, update order with finished and update order with finished. And we can just leave it like that because we again have only one order like we have up here. So, and that's it basically. We don't need to do anymore. We just needed to connect all the signals and slots. They are obviously connected in QML as well, but we don't have too much time here, so we already did that there. And then we just call the functions. At some parts we need to check for the right data type, but nothing too special here, nothing too complicated. And if we run this now, hopefully it will build right away. Yeah, there it is. So you can see you got our machine terminal here, and we can check an order. We can see the data from the order. We can press start processing and finish. And when we take a look at the server here, you can see the requests. So I will start processing. So we patched order number 4. When we finish, we patch it again. When we go back to the main screen, we see another get with all pending orders, and here's the timer that is executing all 5 seconds. So again, this is just an example for OpenAPI by us, and yeah, so we used the API. We didn't use the Q network manager. We just could create it, and it works. So we go back to the presentation, and we finished the hands-on session, and now a few words to our contributions. Like I said, we always try to give back to the projects that we are using, and here's some details from our contributions so far to the OpenAPI generator. Um, First off, there's basic authentication support because before there was no authentication support. Now you can at least put a token or username and password. Next up is Qt support, Qt6 support, because there were a bunch of deprecated functions. We removed them, so you can build it with Qt6 with no errors, and as well a better Qt documentation. So there will also be a documentation being generated with example functions and stuff like this. Yeah. So next up, there was the parameter serialization. So you can choose how your path should look like or how your API endpoints should look like. For example, in the path, you can say, okay, I want to have a comma or an equal sign to assign data to a variable, or in a query you can say I want to have an ampersand or a comma as a separator. Same goes for header and cookie. Um, then the parameterized server support. You only could use an URL. Now you can have a server object. The server object contains a URL with a placeholder. In this case, the environment, and then you can set some variables for this environment. For example, you got a production and a staging server. You can define the different environments, and then later on in the generated code, you can just switch them around. Yeah, those are just some contributions we did there. We are actively contributing more in the future. So if you're interested, you can have an eye out and maybe you will see us there. So, and now to the summary. Um, we generated boilerplate code that would have to be written by hand. And this is always a good thing because it leads to fewer errors. It takes away tedious work. And most importantly, you don't have to think about communication details. So it's always nice to just use the generated code and not use the network access manager and do all the serialization by hand. Can be pretty nice to yeah, avoid that work. So the integration works really well. So you saw we could just use the .pri file, and we could just straight up use the generated code. One thing that could be improved is the QML integration. So we had to use the signal and slots all the time, but that's okay if you think about all the work that we didn't have to do. Um, and some more features are missing still when you look at the OpenAPI 3.0 specification. But as I said, we are actively contributing and maybe we support everything in the future. So if you're interested in the project, in the example project, feel free to visit our blog. There's a blog entry with more details, in-depth details of the generated code. So take a look at blog.basiscom.com. And for more questions, feedback, or help with your OpenAPI in your project, feel free to drop us an email. My email address is marius.dege@basiscom.com. And Basiscom is offering consulting, training, and development service for Qt. But there's also a live Q&A session right now after the talk. So thanks for your attention, and maybe we will see us in the live Q&A right after this talk.